So this video is going to be the first official video of the semester. There was one introductory video. So this one will actually be the start of the material for the class. I will say in the first video, I had not made some required changes on the syllabus that have now been made. So that should be ready to go. So each of each week of the course, and again, this is a super compressed course. It's a lot less time. So it's about 3 weeks per week. So there's a lot going on. So make sure that you're able to set aside enough time. And again, don't get behind on assignments. If you read something or watch a video and don't understand it, make sure you ask questions right away. So this week is a lot of review just to make sure that we're up to speed and that we understood the things that happened at the end of the C++ class. And in case you didn't have me for C++, I think it's a couple of you didn't, then this would be a way just to get caught up on some of the videos I did before, the way I explain things, the way I like to do things, because everybody's different. So this week we're going to be reviewing chapter 10 on classes. Okay. There's also a little bit, I put the video out there, not in week one, but in the top part about structs, because structs are going to be very important in this class on data structures. So structs and classes are very similar. So in this week, week one, I've posted the video on classes. That's chapter 10, chapter 11, maybe a couple of videos on each of those on object-oriented design or with composition in particular. That's the is a relationship that we talked about before. And then also pointers, classes, pointers and how they work together with classes, virtual functions, abstract classes. And there's an example in chapter 12 on lists that we didn't do much with, and we probably still won't. We'll be covering our own kinds of lists soon. Okay. So those are all going to be reviewed. And the videos are out there. So the other thing we're doing this week is chapter 13, which we didn't cover last time, at least in my version of the class. Yours may have, and that's on operator overloading and templating. Okay. So in this video in particular, I'm going to talk about operator overloading. There'll be another video that comes up about the templating and how that works. Okay. So also this week, we're going to have a problem set one. Okay. Again, as I'd mentioned before, I think there'll be a problem set per week. My goal is to have them all out there by the beginning of class. If you want to work ahead, that's fine. But they'll be due one per week as we go along. Okay. So let me switch over here to the server. Okay, so the first thing here, I've got one examples up. I was making sure it worked. The first thing is where I expect work to be. Okay, so again, if you've had me before, you're familiar with the Linux environment. If you haven't, I will have set up by the time class starts an account for everyone, and I've posted a video, and it's up in the top section of Canvas, the introduction, general information, whatever that's called. And it's a video on using Linux in particular, how to use the compiler on Linux and how to use Emacs, the editor. You'll see me do that in the examples as well. Okay. So the first thing we want to do for everyone is to make a directory called CSC 2180. Okay. Actually, make sure your home directory. So when you first log in, when you first log in, you'll be in your home directory, which is home slash your username. So do an mkdir on CSC 2180. It's important. There's no spaces. It's important that the C and the S and the C are capital. Okay. So once you've done that, you've created the directory, you can cd into that directory. Okay. And I created an old directory with the stuff that I've done in previous semesters. I'm going to go ahead and go there now because of the examples that I want to pull up in class. Okay. So the first topic in this chapter is operator overloading. So the way this works, I think the book uses a clock type as the example, and you can read through that. I do encourage you, in fact, it's pretty necessary, I think, to read the chapter in the textbook, same textbook we used in C++. So the clock type just has the hours, the minutes, and the seconds. Okay, so let's say you wanted to have a function where if you had one clock type called, clock one, another one called clock two, that both relate to a time, and you want to see if they're equal. So using the double equal sign, would not have any meaning for that. Okay, so it wouldn't work properly. But you can overload that or change it to deal with your particular class. So it could see is the hour equal to the minute, the second, and so forth. Okay. So I think this would make most sense by looking at an example. So in this example, we're going to look at a point class. Okay. So is this the right one? Yeah. So in this case, we have a point class. The point class has some private member data, X and Y. Okay. Again, the video on classes should get you caught back up to speed on this. This has a public constructor that just sets initial values to 0. And then this uses the one line way to do a constructor. And this can be kind of handy sometimes when you're doing inheritance. I tend to be in favor of doing things more the old school way because I think they're clearer when you're beginners. But this one's okay. So this one is not going to be a problem. So we're just we're sending to X the value of X that we're typing in, and then Y goes to Y. So that'll take the two parameters that come in, assign those to X and Y. Okay, pretty straightforward there. Okay, so again, with this point class, it's going to model a mathematical point, has an X and a Y value. This is in two-dimensional Cartesian plane. Okay, so if we want to do a plus, okay, so what would a plus look like to add one point to the other? Okay, so we're defining this as we're going to take and add to the x value of some other point, and to the y value, some other value, okay, for y, okay, of the other point. So we can do this in a very natural way. If I have a P1 and P2, I can say point P3 is equal to P1 plus P2. Otherwise, I would have to do like add function. I have to say like P1 dot add P2, and it just doesn't look like we expect math to work. Okay. So we're going to do it this way instead. So when we're looking at this function, it starts with the return type. And in this case, we want it to return a new point. So we're going to have a point right here. Okay. We then put the keyword here, operator, and then the operator that we want to overload. In this case, the plus. Okay. And there are some restrictions on that, which I'll talk about in a minute, but we can do a plus, a minus, a divide, um, multiply. We can do stream operators, equality, things like that. Okay. In this case, we're doing the plus. And again, it takes another point. Okay. We're going to send it by a reference here. Okay. Another point we're going to call other. Okay. We have some constants in here. This constant keyword protects the point that we're sending in from being changed. And this is necessary because we're sending it in as a reference. Okay. This const over here protects the point on the left side of the plus sign. Okay, so basically the other is on the right side of the plus sign, and the original one is on the left side. So this keeps either of those from changing, which makes sense. If I have point 1 and point 2, I create a point 3 by adding those together. Neither of those 2 points should change. Okay, so it's important that you put those constants in there. Okay, so one other thing the chapter talks about is the use of the this keyword. So where this comes in is this refers to the object on the left-hand side of the equation. Okay, the left-hand side of the plus sign. So we can't just say X here because it will be confused which X we're talking about. And we can't know the name of the object being called. We just know it's a point. Okay. So this is shorthand. Whichever object of type point calls it, this will be the name of that object. Okay. So in this case, we're going to return for our answer here, our point. So we're creating this point, return a point that's going to create from this X, okay, that's the X on the left-hand side of the plus other X, which is referring to the point on the right-hand side, okay? The same thing for this Y plus other Y, okay? This calls the point constructor right up here, sets those values, and returns that point, okay? So that's what that does. Pretty straightforward, hopefully, okay? If not, back it up, watch it again, okay? We then have the equality operator here, the double equal sign, In this case, we want to see, okay, if X is equal to X and Y equal to Y, point's equal to point. Okay. So there's no default behavior on this. We have to define it. So again, this one is a Boolean operator. It's going to return a true or a false. We have the operator equals equals. Okay. And again, we have the same idea before. We're sending along another point by reference called other. So we're protecting it with this constant. We're protecting the point on the left-hand side of the equal with this constant. Okay. And then we're just doing this Boolean equation here, or Boolean expression. We're doing two things. They're separated by the ampersand, which is an and. So both have to be true for it to return true. The two things it's checking, if this X equals other X, and this Y equals other Y. Both of those are true, returns true. If either of those is false, it returns false. Okay. So those are the two basic operators. And let's take a look at how we do those before we get on to the other things here. Okay. So in this case, we have, we're going to use our constructor here to declare two different points. Okay. Point P1 has a value X equal 1, Y equal 2. We have point P2, which has an X equal 3 and Y is equal to 4. Okay. We're then going to use the overloaded plus operator that we just defined. So we're going to say point P3 is equal to P1 plus P2. That could have been on a separate line if you wanted. You could have just said point P3 semicolon P3 is equal to P1 plus P2. That would have been fine as well. Okay. We're now going to use our, I tend to do it this way instead. There's some debate on how to do that, but I like this way. Okay. So we're going to say if P1, point P1 is equal to point P2. Okay. So again, when it calls that, this will be this will be the other. Okay. It's going to check to see if those 2 points are equal. Okay. Then it's going to either say yes, that they're equal, or no, they're not. Okay. In our case, it should say that they're not because they're not equal. Okay. And then when we run that, it should do that part. But now let's go on to look to the little more complicated idea of overloading the stream operators. So remember, the stream operators are defined outside of the class. They're kind of their own class, their own implementation with these stream operators. And these are the output stream and the input stream. Okay. And we use the two less than signs for the output stream, and we use the two greater than signs for the input stream. Okay. So we can define those as well, and we can use them as and part of a cout statement to automatically print a point. So we can put what we want to be the printout of the point. Okay. We can also use them in a cin statement to be able just to take values off of the input stream and add them into a new point. Okay. So we're going to do both of those. And for both of those to work, we have to introduce a new topic as well in this chapter. And that's the idea of a friend function. Okay. So a friend function is a function that's not in the class. Okay. So in this case, these OStream and iStream operators are not in the class that we're developing. Okay. The plus and the equal are in the same class. There's a version for each class, so we didn't have to deal with this. But in this case, I want the function that I'm creating to be able to have access to the private data of another class without having to go through the accessors and mutators. Okay. So you can do this with any function. So if I have a boat class, the homework's going to talk about boat classes. If there's another function not inside of the boat class, but I want to give it those same privileges as if it were, I can declare it as a friend function. And you declare the friend function in the class, not in the function that wants to be a friend. Okay, so that's an important distinction. It's also important that you have to use a function prototype for that. It's the only place it can be. So in this case, I'm going to do two function prototypes, even though I'm going to define the functions right here, wouldn't really need to do it that way. Okay. So this first one here, we've got the keyword friend, we've got the OStream ampersand. Okay, so this is going to return um, an a reference to an OStream type, okay, which is what it needs to go into the cout, okay? And the operator here is the less than, okay? And it's going to take this OStream reference OS, okay? And then it's also going to take reference to a point called a point, okay? And the point is not going to change. We'll put the constant there, okay? So we don't have the constant on the OS stream because the OS stream is going to change, okay? And then on the other end, or the other way, is on the next one is the friend function for the IS or the iStream, I guess, operation. Okay, the operator is the greater than. It's going to take some input stream function IS and some point. Okay, and again, we're just putting the prototypes here, so there's semicolons at the end. And we're going to define them just in a minute, but we need that separate prototype because they're friend functions. And again, friend functions allow us to access the private data inside of a class. Okay. So we're going to implement this now so we know what it's going to look like. It's going to look like just like up here, the OStream ampersand operator less than. All this stuff is the same. Okay. Inside of this, we're going to have our output stream reference. Okay. We're going to have our two less than. We're then going to put, so this is what we're printing out when we just say cout P1, that's a point. Okay. It's going to put the left parentheses, what the value of point X is. This is why it had to be a friend function. So point.x, okay. Then a comma, and then point.y, and then close the parentheses. Then we're going to return that output stream object. It'll go right into the cout, print out on the screen. Okay. The iStream operator looks very similar with the greater than, but in this case, we're going to send along the point.x and the point.y on to that operator. Okay. So now we can finish up this example. Okay. And that we can now, here we're doing a cout on P1 colon. That's just going to print that out. And then we can directly put the P1 right here. Okay. No further print. That will then go up and take and print out this thing that we just did. Okay. That's how that works. Two examples of that. Okay. Or three, including the doing the P1, P2, and P3. Okay. And then with the overloaded greater than operator, we have this new point P4. Okay. We can just say, we've got our message here, enter the coordinates in the format, just X and then Y with a space in between. We can do a CN onto P4, and then we can cout, use the cout again to get that in there. Okay. So let's go ahead and compile this and take a look at what it looks like. So a Control X, Control C to save, if you've forgotten that, and then we want to say yes. Control X, Control C exits, sorry. Ask you if you want to save. You say yes, and it takes you out to nothing, okay? And then I can do a G++, okay? I want to do a -O, calling this point example.exe space point example.cpp, okay? Did that. If I do an LL, there's a lot of crap out there, but basically I will have I can do a point dot period slash, okay, the point, too many points around, ex.exe. When I run that, okay, it gives us that P1 and P2 are not equal, which we expected, and it gives us using those cout operators, or the output stream operators. This is the format we've got, the 1, 2, and the 3, 4, and then the 4, 6. Okay, we can see that this is correct and that 4 is equal to 3 plus 1, and 6 is equal to 4 plus 2. So the plus is working. Okay, it's now asking to enter the coordinates for the fourth point. Put it whatever I want. I can put 44 and 66. It's going to now print that out, and it prints that out correctly. Okay. So that's the idea behind operator overloading. So you often see this. It's a common example if you do like a fraction class, if you wanted to add two fractions together. Rather than having to define a fraction class, where you'd have to say fraction 1 dot add fraction 2. You could just say fraction 1 plus fraction 2. Okay. So that's the basic idea there. But there are some restrictions we have to keep in mind. Okay. Those are that, first off, you can't change the precedence of an operator. Okay. So if you redefine the addition and redefine the multiplication, and they're in the same equation or the same statement, the multiplication will happen first. You can't change that. Okay. You also cannot change the associativity. Okay. So the arithmetic operator is going to go from left to right. If it's just a bunch of, if they're this plus this plus this, the one on the left happens first. Can't change that. Okay. When you're defining these, we can't use default parameters. It doesn't work. Okay. You can't change the number of parameters that the operator takes. Okay. So the plus operator takes 2. Can't change that. Okay. You can't create new operators. I can't say I want a special, ampersand operator. Doesn't work. It has to be an existing operator for it to work. Okay. There are operators you can't overload, and some of these we've seen, some of we haven't. You can't the dot operator, for example, like point.x. That's something that can't be changed. Okay. The size of is another operator that can't be changed. Okay. So you can't redefine how the operators work on built-in type. So you can't redefine. So for example, the division operator, the slash division operator with 2 integers returns an integer solution. You can't override that to make it return a double. Okay. Doesn't work. You can't change any of that stuff. Okay. So you can overload the operators if there's some kind of either for your custom created types or for a combination of custom created types and built-in types. Okay. So if you wanted to define a function to add an integer to your point, you could do that. Okay. So that's one of the big points about this section. So to review some other things, we've got this pointer. This pointer refers to the calling object. Okay. We'll use that as a shorthand for that. We'll use that a lot as we develop our further data structures. Okay. Then we talked about friend functions, which is it's not a member of the class, but it has access to all the private members. Okay. We use that when we need to make things work. Okay. So the book talks about overloading the binary operators. We don't do that a lot. So I think I'll skip that as far as the video, and there won't be any homework on it. But if you want to look through it, there's always stuff that may come in handy someday for sure. There's just too much to cover, especially in a quick class. Although I don't cover that during the semester either. Okay. Then we talked about the stream operators, how they have to be friend functions to get them to work. Okay. See if there's other things that we need to do before we go on to the pointer things. There's a section in there as well on overloading the unary operators. Okay, so there are not a whole bunch of unary operators. There's the plus plus, the minus minus. I think those are the main ones that we use. And those can be changed if you want. The book gives some examples on how to do that. So if you want to have a different way to increment rather than the normal one. Okay. So lots of stuff about that. Okay, but that's the basic thing. Okay. So the next thing we're going to talk about here is classes that have pointer member variables. Okay. So whenever we have a member data that has a memory variable like a pointer, okay, so a pointer again is just a pointer to a memory address, a location in memory, okay? So whenever we're creating a class that has member data that's a pointer, there are some things that we have to do, okay? So there are some problems that could happen, okay? So To resolve any potential problems, we have to do the following. We have to explicitly overload the assignment operator. Okay, the assignment operator has to be fixed to work with the pointer data. Okay. We also have to include a copy constructor, and we also have to include a destructor to free up the memory. Okay. And we'll take a look at an example of that as well. And there's a fairly long example in the book that talks about all that. Okay. Including an example on page 959 with complex numbers. You know, and that turns out to be a fairly interesting program, I think, that if you have the time is probably worth going through and at least understanding what's happening on that. Okay. So here, let me make sure I'm not missing anything. And then let's go on to the other example. Okay, so this is an example of how we have member data in our class that is a pointer and what we have to deal with that. Okay, so in this case, we have a class called my class. Okay, again, I like to do it that way. And it has, yeah, it's okay. Okay. And it has one member data that's a pointer to an integer just called data. Okay, that's it. Remember the star here could be there, it could be over here, it could be okay, either way. So we have a constructor here, okay, and again, this uses kind of the one line deal here. Okay, we're creating the data. We have the new keyword here to allocate the memory for our pointer, and we're putting in an int of 0 for that. Okay. Then our destructor has to delete any memory data that we have. So our data is called data, so it's going to get rid of that. Okay. We now have a copy constructor. Okay, so again, the copy constructor is going to allocate new memory. So we're going to do the one line function here, which it makes it most straightforward. Okay, so it's the my class because it's the constructor has the name with no of the class with no return type. Okay, it's going to take some other instance of my class, some other object as the parameter. That other is not going to change. So we have a constant, it's a reference to the other, okay? And then we're going to set the data for the object we're creating, okay, to be equal to allocate a new integer, okay, on the other data, okay? So we're going to dereference the address of that other data. Okay, that's what that's doing. Okay. We then have to overload the assignment operator, okay, the equals operator. So we're doing that. So we've got, this is going to return the address of a my class object, okay? And here's the operator equals, okay? It's going to take this other. Again, that other is a reference and it's a constant, okay? So we can't change it. Okay, so we're going to say if this is equal to the address of other. So what that's saying is if the object that we're copying is the same already as the object we're copying to, the from and to are the same, then we're just going to return this. Okay. We're going to do that so we don't have to go through the work of assigning something to itself. Okay. So if we have, if we're saying like from our point class, P1 is equal to P1, there's no point in going through the works. We're just going to return the one we have. We could just as easily here return other, but we're going to return this. Okay. Again, dereferencing it with the ampersand or with the star. Okay. But if we get to this point, okay, this return gets us out. If that's the case, then we're going to set the data. So the dereference data, so that's what's stored at data is equal to what's stored at the other dot data. Okay. And then we're going to return the this, okay, the address of the this. Okay. So That's how that's going to work for to overload the copy assignment operator. Okay. And then we've added an accessor in here, which returns the value that the pointer points to. We've had a mutator, which changes the value that it points to. Okay. And then we have our set value function. And then we're using the copy constructor here. And then we have the set value here for this other one. And then we're using the get value here after we've done that, just to see that it works. Okay. So that should work without too much trouble. Okay. So what that leaves for this chapter, has been a long video anyway, is using function templates and templating. So I will have a separate video on that should also be available probably right now. Okay. So take a look through this, look at the problem sets, make sure that you understand what's going on. If not, we'll be setting up virtual office hours. There'll be an hour during the week that we can meet together. If you can make it, it's optional. You don't have to be there. I'll try to get a sense of when the most people can make things. And there should be a discussion board, and you can always text or email me if you have questions.